This one? Yeah. Good evening, everybody. Hello. Hello. All right, great. My name is Brian. Welcome to React Native NYC. Great, awesome. And I will be your host for this evening. Uh, Quick things. So tonight we have two awesome speakers. We have Stan Bershadskiy. He's going to be speaking about putting the native in React Native. And we also have Harry Wolf speaking on React Native Art in D3. Before I do a full intro of our speakers, I just want to go over a couple of things. First of all, I want to thank all of you, all of the attendees for coming here tonight. Without you, we wouldn't have a meetup. So thank you very much, and a round of applause for yourselves. Next, I want to thank Tom Goldenberg, which is the founder of this meetup. He is the person that I co-organized this meetup with. And I want to thank you for allowing me to be a part of this. And I also want to make a quick announcement. Tom has gotten the opportunity to be in an accelerator in North Carolina for a startup that he's just starting. So a round of applause for that, please. Next, I would like to thank Oscar Health for providing this space, the food and the drinks tonight. I want to thank Julian and his team for facilitating us organizing here tonight. And I also want to thank Andrew Schultz, the Director of Engineering here at Oscar Health, and I want to bring him up for a few moments to say a couple of words.
Thanks, Brian. Welcome, everyone. I'm Andrew, one of the directors of engineering here at Oscar, and we're really excited to have you here. We've been using React Native for, I guess, about a year at this point, first on iOS and now on Android. So really excited to see the community come out and see some awesome stuff getting built on top of it. For those who don't know what Oscar is, hopefully some of you have seen our Subway ads. Although they're a little less prevalent this year than the past. Turns out lots of other startups are buying Subway ads these days. We are a health insurance company based here in New York, but we also offer insurance in Texas and California. We got started with the premise of making health insurance simple and smarter and easier to understand. So we do that by taking a look at all the data that we get from our members, seeing how they're interacting with the healthcare system, and building easy-to-use member applications. On top of that, things for all of our internal teams so they can help our members better. If that sounds like an interesting problem that you'd like to help us solve, we're hiring across the board. We are using React Native, so you get to keep doing that here. There's a bunch of Oscar engineers around, Julian here up front, Evan over there, and a bunch of people in the back I see as well. So we're the people without name tags on mostly, but actually, yeah, if you want to raise your hands, folks. But yeah, come and talk to any of us afterwards. Really excited to have you all here.
Thank you, Andrew. So to start the night, one second, I have to type my password in. No, I'm good. Thank you, Julian. So to start the night, our first speaker of the night is Stan Bershadskiy. Like I said, he will be speaking about putting the native in React Native. And just a little bit about Stan. Stan is a New York City-based architect at Modus Create, as well as the co-organizer of NYC.JS. It's one of the largest JavaScript-focused meetups in the city. Stan has specialized in JavaScript framework development for over 5 years and recently co-authored a book called React Native Cookbook. It's a Packt Press book. And he will be also doing giveaways tonight, so pay close attention because I think the giveaways are based on some of the points that he'll be talking about. So a round of applause, please, for Stan.
Hello. Just give me 1 second. everyone hear me okay, or should I use the microphone? Microphone? Okay. Yeah. All right. Does everyone hear me better now? Awesome. All right. Hi, everyone. My name is Stan, as mentioned earlier, and I'm going to be talking about putting the native in React Native. So this talk will focus on React Native, obviously, but we're going to be looking more at the native side of things instead of just the JavaScript. So let's dive in. So a little bit about me. Brian gave an awesome introduction. Thank you. So like he said, I'm an architect at Modus Create, NYC.JS, blah, blah, blah. I've been working with React Native since version 0.08, 0.06. So this was back when no one did class foo extends react.component. This is back when we did react.create class and no one knew what ES6 classes were. So yeah, that's how far it's changed already, for the better. A little bit about Modus Create. Modus Create is a product studio. We specialize in mobile and web apps. What that means is we come in, we help companies to either migrate from a particular framework to another framework, usually legacy to be something more modern. We come build an idea from the ground up with the company. We specialize in React apps, React Native, Angular, Ionic, any popular hot technology you want to do, we could help you out with. We are partnered with GitHub for their enterprise support, Drifty, Ionic, Sencha, if anyone remembers what that company, knows what that company is. Yes? Okay. So a lot of our work recently has been Sencha to React migration. I'm sure you might understand why. And we have plenty of authors, including myself, speakers. We host our own conferences. And yeah, that's about us. So let's dive right into React Native. Oh, and sorry, I forgot to mention the most important thing. I am one of the co-authors of a book called React Native Cookbook. It was recently published. My co-author is Chris Fell. I don't know if you're Chris Fell. No. Said he was going to be here today. But yeah, so I wrote that book with Chris Fell. We like to think it's the most exhaustive piece of information on React Native. We go from writing your hello world to multi-thread processing using native like GCD on iOS and then over there deployment. So we cover the whole gamut of React Native development from beginner to advanced level. So let's talk about React Native and what's so special about it. So let's step back before React Native. React itself is an ecosystem of tools. So React powers a bunch of things. It powers React Native, powers a thing called Relay. It's used hand in hand with React Native. And GraphQL, that came with Relay. Question, who's used Relay and GraphQL with their React app? Yeah. It's too hipster, that's what it is. That's the problem. But it's a really cool piece of technology. I just wish there was more adoption of it. Unfortunately, with parse, it kind of, yeah. Flux. Now here's a better question. Who uses Redux with React Native? Or React? That's why. Do you use Flux? Do you use Redux or Flux with GraphQL? Okay. Awesome. Awesome. No, because I've seen use cases where we've used a Flux implementation like a Redux or Alt or whatever and a GraphQL behind it. Cool. Flow, the static type checker. Who uses Flow? Who uses TypeScript? Cool. All right. And finally, Nuclide. Who uses Nuclide? No one. Why? It's slow. Is it slow for you? But some really, really smart people are working on the Nuclide team. Primarily the guy who wrote the foreword to the React Native Cookbook, Christopher Trudeau, who's one of the authors of React Native. So he's on the Nuclide team now, so hopefully it'll get a lot better. Now, React itself powers a lot of little things, and that's the whole point of React itself is it's agnostic to what the deployment target really is. So you got web, React DOM, iOS, React Native, Android, OS 10, or Mac OS now, tvOS. That's already, tvOS is baked in right now into React Native. 0.41 has proper tvOS support. Before it was a fork. Unified Windows Platform. Thank you, Microsoft, for putting a lot of money. into it. You could run React Native apps on your Xbox One, if you ever want to do that. And VR, that's the latest cool thing. Now VR is all the popular, so you could use React and make a little VR game or app or whatever. Cool. So quick question: what is React's new core algorithm going to be called? Who said fiber first? Fiber? All right. Book for you. So, let's talk about React Native. Now, React Native, simply put, is a library. I don't know if you've seen me speak before or one of my colleagues, Jay Garcia. We use this slide a lot. It just simplifies React Native really well. It takes your JSX code, which is all React. That's all React JSX, and it binds it to either Cocoa Touch, which is the iOS SDK for rendering the UI, or UI kit, whatever you want to call it, and the Android SDK or Android UI SDK. I don't know what they call it these days. It has a custom layout system that's been rewritten probably 3 times already. Every time getting faster and faster. Custom animation system that's also getting faster and faster. And then it has a whole suite of technologies that it uses into. If you look at the dependencies, you might as well just go crazy, but it's cool. The applications run at near full speed. Why near? Because you still have to communicate. JavaScript has to get interpreted through the interpreter, converted to the message has to get converted and communicate with the native layer. So that part, that bridge, we like to call it the React Native bridge. That's the slowest part of React Native, unfortunately. Does it impact you? Yes and no. It depends on what you're trying to pass through the bridge. It could burn you really, really bad, or you might not feel it at all. And for most business applications, you're not going to notice a difference between a truly native, Objective-C Swift app or Android app, Java Android, and a React Native app. The architecture is scalable because it is built on React, and you could extend it. Like I said earlier, the tvOS functionality came from a fork. The macOS stuff also came from a fork. I think there was talk of a Apple Watch, so on and so forth. There's the architecture to add your own platform, and I'm going to get into it, and I'll tell you what the secret is of that architecture, why it's so extensible in a little bit. And it's BSD licensed, so that's cool. What's React Native's core dependency? It has one single core dependency, the most important one. Okay, who was the first? Okay, you get a book. A few more, and then we got more giveaways. So, all right, now let's look at the three main parts of React Native, the 3 threads. There's the shadow queue, which is the layout engine. So that's the part that's going to say, where I want what. It's called React Native CSS. It looks a little bit like CSS. It looks kind of like React CSS. I like it more than Web CSS. But it's not Sass, but whatever. But it's a C-based layout implementation. It's pretty damn fast. It gives you 2 options. Either you could have Flexbox with the Flex implementation, very similar to the modern web Flex implementation, or you could have absolute positioning. Most people use Flex. It makes your life a lot easier. And the original designer said, between Flex and absolute, you really get what you want. You could mangle them together and get whatever kind of layout you want. You don't really need a third type of or whatever other layouts. The main thread is where all the native stuff goes. So that's responsible for rendering the native UI widgets. So be it your UI button on iOS or your text field, your edit text on Android. So that part is rendering the stuff to the screen. And your JavaScript thread is where all your business logic happens, unless you offload it to the native side. We'll get into that a little bit later. But generally, all your JSX, your HTTP requests, they're all going to sit in the JavaScript thread. Your fetch calls, they'll all be there. And that's where the business logic occurs. So how does that actually work while your application is running? Because everyone wants that 60 frames a second, right? So that's why we have asynchronous threads. So nothing gets blocked, and unless you do something stupid, of course, but let's hope you don't. So you have an event loop running at an ideal 60 frames a second on your JavaScript thread. And what happens? You press a button, you tap a button, let's say. It's going to make a JavaScript call to the React Native bridge. And what that is, it's going to send a message and put it on the main thread. That message is going to get interpreted and going to call that, is going to call the native call associated with that message. So if it's like a button press, there's going to be, there's a registry of JavaScript modules to what's happening on the native side. And let's say on press, it's going to, your JSX on press will call the UI button on press or on touch or whatever it is. After that occurs, then it's going to fire an application event. It's going to emit an event from the main thread, and it's going to let the JavaScript node, hey, the JavaScript thread know, hey, there was this this event happened, and the event emitter is going to emit it to the designated target. So, be it your component's on touch handler, and that's going to say, all right, this was completed. Now, go do what you wanted to do. So that's how it works. Hopefully at 60 frames a second. Every single interaction you make with your application does this in a really high level form. Any questions so far? Okay. What was one of the first uses of React Native in production? Not pages. It was groups. Yes, it was. Because groups was iOS only. And then when they did the Android support, that was with ads. So Ads Manager came with their Android support. They had to build Android support. They actually showed off Android support, and then, they showed off Ads Manager, and they're like, oh, hey, we did Android support. And we did it because we had to make we had to make Ads Manager be multi-platform. So, and that whole Facebook targeting two platforms, the two core React Native platforms are iOS and Android. Now, I'm going to tell a little story. Please don't take any assumptions. Take it everything like for a grain of salt. I'm not trying to spread any opinion or anything. It's just purely, I don't know what the word for it is, but hypothetical, let's say. Let's say you have a family. You have the mother, the father, happy family, and they have two kids. Now, the mother and the father are Facebook. Okay, so they have their two kids. The daughter is the star student. She's she gets A grades, never gets into trouble. Their life is pretty easy. Who would like to guess which platform the star student is? Yes, no. Anyone? iOS. Now, the boy, let's call him, he gets B's. He doesn't get C's, but he gets B's. He has a nice smile. But when it comes to parenting him or for him behaving, he has those occasional troublemaker tendencies. Who'd like to guess what the boy is? Bingo. And that's exactly how Facebook treats the two platforms, for better or for worse. iOS came first, naturally, and then Android came later. But the way Facebook did the Android the Android functionality is an extension of their architecture that they built for iOS. So I'm going to get into it a little bit. So here's how React Native for iOS is structured. You have your UI application, UI window, UI view controller. These are all common iOS. Anyone who's done Objective-C knows these are the basic, parts of a basic, iOS application. And then you have an RCT root view, which is just an extension of a UI view. So that's like your standard React Native iOS application. So then what we have is the JSX classes. They go through remember I said when you make any sort of call, they go through the bridge and they get translated to the native layer. And then the native layer maps the JSX class to the React Native class. And then that gets mapped to the UI kit class. So view, RCT view, UI view, scroll view, scroll view. You'll see the RCT prefix. Obviously, that implies React. Anyone want to guess what picker goes to? UI picker view. That's the weird one. I don't know why iOS decided to keep it as UI picker view, but they call it UI picker view. But yeah, so you see a common pattern. So that's how all the JSX to iOS stuff gets bound. Now let's go into Android. Android, similar structure. You have an application. in your Java code, you'll see it's main application.java, whatever. That's your that implements something called React application, but that just gives a little bit of an extra sugar on top of it for no real reason. Then the core logic is in the React activity. That's usually the activity that gets fired off to start your React Native application. Inside of the React activity is a React activity delegate, which actually is responsible for all the React bootstrapping, React Native bootstrapping, and that creates a React root view, which is a simple frame layout, but it has it knows to point to the bundle and so on and so forth. So it's similar to the React RCT root view for iOS. So they follow a similar architecture pattern, and you'll see the same thing for Windows or any other platforms that you choose to go to. And how does it all work in Android land? So you have your JavaScript and your JSX. That's mostly the same. So who here has done a React Native application for iOS and Android and deployed it? Okay. Well, okay, deployed, almost deployed, beta, whatever. Working. Almost working. Yeah, the iOS part works and the Android not so much. Is that usually what it? Yeah. How much code complete? How much code similarity do you find between the two? How much? 85? Okay. Is that about common? 90? 98? Yeah, I mean, if you listen to the Brent from Exponent, he says you should do everything in JavaScript, and then you could even be at 100, but you know, so that's cool. So it's mostly the same. Your JavaScript's mostly the same. Your only difference are mostly going to be style, UX, how your interactions work, and so on and so forth. Functionally, you're going to try to keep them the same, unless there's something missing from Android or iOS or vice versa. So then it goes into Magic Land, the NDK, the SDK, and JavaScript core. Now, take a notice of JavaScript core. JavaScript core is WebKit's JavaScript compiler. What the hell is JavaScript core doing on Android? Since Android is now bundled with Blink or whatever Chrome's implementation is. Why do they have JavaScript core? Here's why. Because your JavaScript will set an event called, let's say, top touch start. This is when you start scrolling a list view. That's going to go to the NDK, which performs native calls in C++. So it's going to execute you go through the JNI and execute JavaScript core. And the JavaScript core is going to translate that message to RCT scroll view. Wait, RCT scroll view was the iOS binding, right? What is the iOS binding doing in React Native for Android? Then what's going to happen is it's going to go through a module registry and get translated to the UI manager module, which is the Android-specific module. So that's kind of the secret sauce of React Native, how they're able to target all these different platforms. All you really have to do is implement that last, I don't know, third, which is the module registry. You have to implement everything that it does on iOS using the iOS bindings, and then at the end there's a module registry where you just have to register your platform's component to that iOS representation. So like I said, they like iOS a lot. iOS is their first priority, so everything's going to go iOS first. The messages are going to look like iOS, React Native for iOS messages. And then at the very last moment, your implementation is going to change, and it's going to go through that module registry. So that's how they're able to implement all the other platforms. Any questions on that so far? Is that clear? Cool. So now let's talk about blending native and React Native. So how are we gonna, take our native apps and our React Native, and how we're gonna bring them together? If you guys know, the iOS Facebook app uses React Native. You won't see it, you don't know about it, but there's parts of it that are React Native. And how is how they blend it together, so to speak. And I'm gonna show you how they do that. Other Instagram, Airbnb, a lot of the big apps, they have a mixture of iOS components or Android components. That's the parent application, and then they have a React Native little sub applications inside of it. So the basic architecture is you have your native app, you have the React Native section, then you have like your native view controller, and then they just talk back and forth. Now that's simple. That's high level. I mean, let's really see how they do it. Stop. Demo time. going to just do a quick demo of how it works. Okay. So what I have here is a simple iOS app. If everyone can see, let me just zoom in a little bit. So on the white background area is a pure iOS native Objective-C app. The username field was added with the storyboard, and inside here on the bottom is a React Native embedded app. So think of it as like Facebook. You have the main thread, and then you have like your like button. That would be a React Native component. So what happens is, what we could do is when I type in, not lag, it'll update on the UI text field. So this is exactly what's going to happen. The two applications can easily communicate with each other seamlessly, so the user won't know the difference. Obviously, this is a super trivial example, but this is exactly what's going on behind the scenes. And vice versa if you want fancy two-way binding. Just to show that it's pretty responsive, yeah. But that's exactly what happens. You could have your iOS app talk to your React Native app, and your React Native app talk to your iOS app. So just to show you quickly how that actually works behind the scenes. Okay, so how does it work? So you have your iOS application. Inside you have your main view controller. Then you have an iOS text field. So you would add that either by code through through Objective-C or Swift, or in your storyboard, whatever. And then you have an embedded view controller, and that's going to sit. That's your React Native application is going to sit inside of there. So you're going to the same way you bootstrap your React Native application for a regular app, you bootstrap it for this embedded view controller. So what happens when you actually start communicating between the two? So you have your bridge, the React Native bridge. That's responsible for all communication going anything between React Native and native. You have two important components. You have the event emitter, which we talked about earlier. That's gonna communicate to the JavaScript world of things. And then you have a native module, which could be anything. So that's a React Native module. So let's say your text field, you do an on edit change, which means typing. That's going to communicate to the bridge and say, hey, you're going to have first it's going to go to your view controller and say your Objective-C action will fire. And then I'll say, hey, React Native bridge, fire on the event emitter, dispatch this event that I updated the event. Then in your JavaScript, you're going to listen on that event and update your React Native UI from there. So that's one flow. The second way is from React Native to the application. Similar concept, but it's much simpler in that way, where you'll go to the bridge and you'll just call your native module. And your native module will then just interface with your iOS UI kit. Native modules are a simple thing in React Native. Anyone who's done them compared to like PhoneGap or Cordova, doing a native module in React Native is a walk in the park. So yeah, so that's really how Facebook does it, how all the applications blend those two, and blend the communication between the two. I'm not going to show you the source code because it's not going to be very easy to see, but if you just go on GitHub, you could just search for the React Native Cookbook source code. It's all public. It's all there. All these examples are all there, so feel free to look at it there. So last question, what's the... All right. I actually have one more, I think. That was easy. Further learning, the places I like to go for, other than my own book, other than the book for learning about React Native, their official documentation has recently got revamped a good amount. It's gotten a lot better, especially the Android part. Before there was a lot of discrepancies between the two. Now it's gotten a bit better. Shameless plug, the Modus Create blog. We blog a lot about React Native, so you'll find a lot of tutorials and nice, good things to know there. Use React Native, that's an awesome site. And I found the React Native GitHub issues. that's a great place to learn about how React Native really works under the hood. You'll see a lot of the core committers talk about stuff there, give their explanations, and it's pretty peaceful so far, so it's pretty good. One last question, because I forgot this slide. How many stars does React Native have on GitHub? 35, no? Well, it's like 43, but close enough. There you go. All right. That's about it. Any questions? Oh, sorry. Thanks, Tom. Last thing, if people check your seat, you might have a Modus Create sticker on the side. Anyone have any stickers? 1, okay. 2, 3. There's 5 of them. All right, we got 5? All right, come by to me in a minute. You guys all get free ebooks. So I just need your emails and you guys get free ebooks. And for everyone else, there's vouchers over there for coupons. It's 50% off the ebook and I think 10% off the hardcover. And we're going to be doing more and more giveaways. I'll be talking at more events, more giveaways, probably something on like Twitter and Instagram. So thank you. Any last questions about anything I talked about today? I have it, but that's pretty cool. But you would just really just fire events. I would probably just fire events onto the React Native layer to keep track of the state of whatever my parent application's in. Fortunately, if you use like React Native Router Flux, like you could easily jump between the navigation if you have to navigate through your React Native application, and then you would have to just, yeah. Generally iOS applications run faster. No matter Android, not Android, I'm sorry, React Native, not React Native, iOS just is a better development platform in my opinion. The applications will run faster. If you go apples to apples, same app, you'll probably see similar things. Where you might see a difference is if you use animations, because then you could offload things of the animations to the native driver and use the GPU. And there's discrepancies between what iOS supports and what Android supports. The funny thing is Android supports more right now than iOS in terms of native driver, but they're trying to align those up together. Okay. Uh-huh. So you're saying if you build for like a React Native for iOS first and then moving to Android? So depends on how complicated your app is. I've done it. I usually follow a very simple procedure. What I do is I go through the whole code base. Everything that ends with the suffix iOS, meaning it's specific to iOS, I destroy it. I just delete it. Then I run that. It's kind of like test-driven development, and then everything's gonna crash. And then, but one by one, I start finding whatever the Android applicable way is, and then I bring it back until I get the application working. Then you have to deal with styling. That's usually the biggest issue. There's some issues with like backgrounds and fonts between iOS and Android. So, but it's mostly visual, and that's where you do. I've taken a relatively complex application, and to get it running from iOS to Android, it took me like a day or two, and that was mostly not even the React Native part. It was mostly to get like maps working with like the Google API and all that crap, and like YouTube videos. Well, YouTube videos are a mess on Android. If like the React Native YouTube component's still pretty, I wouldn't say, yeah, it's pretty immature because the iOS one was out a while ago. So when you start interfacing with like native stuff, that's where that's where your time could expand, because you have to replicate whatever you have native, like whatever native code you have from iOS to Android, if there's not already a third-party component available. If everything is first party, then you should be pretty clean. Like going from one to the other, it should probably only take you a day or so. Yeah, but in the book, there's a strategy of like writing code that fits for the best practice for handling both platforms, when to do platform specific, and so on and so forth. Yeah.
Can you explain GraphQL and Relay and React Native for people that might not have ever used it, and why you might use it?
Why you might use it? I wouldn't know because I haven't used it.
Oh.
I'll be honest, because most of the use cases I've come across when I have to build a React Native app, there's usually just a standard RESTful API, and it just makes my life so much easier to just to make fetch calls to the API, have it handle all the data, return the data, and do whatever I need to manipulate with it on the JavaScript side of things. I know at Modus we have a big project for React for Web where we really use GraphQL, but we kind of worked with the team there to set up their middle tier to support all that. We don't use Relay. We use Redux with GraphQL. Well, they have GraphQL, but we use Redux as the data flow. Fine.
Okay.
Sorry, I wish I could answer that better. That's it. All right. Thank you, everyone.
Okay, next up we have Harry Wolf speaking about React Native R&D 3. Quick introduction, Harry Wolf is a senior UI engineer at MongoDB and an active open source creator and blogger. He's located here in New York. Here he is. And he loves discovering and playing with new software that makes it easy to create new applications as quickly and as easily as possible. At his previous job at Chartbeat, he built their new iOS application from the ground up in React Native, and he has remained involved and interested in the React Native community. So here he is, Harry Wolf.
Thank you, Brian. Sounds like something I wrote. How's everyone doing today, this fine Wednesday? Oh, okay, woos. Oh, that is a very small resolution. 1 second. So I could describe the slides to you. I mean, it's here, but it's not there. So this talk I've given about 3 times before, but this is the first time I've given it in person, so it'll be very interesting to see how it goes. Previously, I've just been talking to myself on my computer with my wife in the other room, kind of just saying stop, but that's how it goes. Abracadabra, yeah! Thank you. Now that is React Native. Okay, so without further ado, I'll just start. So my talk is React Native and D3, 2 fun buzzwordy topics. Yeah. As Brian said, I currently work at MongoDB as a senior UI engineer. I also have a blog where I write about tech stuff. Sometimes I write about music. Whatever I like, I write about it. If you want to read it, you can. That's hswolf.com. I also tweet with a handle that might be hard to remember if you already know my blog address, which is hswolf, and then GitHub as well. I'm not very original. Once I find a thing I like, I just kind of repeat it. But it's Harry, middle name Spencer, Wolf. Extra F for good luck. Always need good luck, right? So before I jump in, I want to talk about what I know about React Native, just to give a nice preface. My phone's buzzing. Just follows, lovely, okay. So before Mongo, I worked at a company called Chartbeat, where I was, yes, there are representatives here, former coworkers. Hello. There I was fortunate to actually rebuild the iOS application, starting with React Native from the ground up. This is a video of the application in action. This is entirely React Native. A list of all top articles. You can see details view. And at the top here, you can see an actual graph, which is powered by D3. That graph itself took about 3 full months to get into a production-ready version to launch, so it was a fun feat. But just to show some background on it. So I'm not going to delve into this too much because you already got an excellent introduction before. But React Native is a framework for building native applications with React. If you know React, how to make an application in React, you've already covered a lot of ground to make a React Native application. Fun fact, the first time I was actually professionally working with React was with a React Native application, this application, so whatever. This is from the website where you can build mobile apps using only JavaScript. Cool. And this is what a React Native component looks like. So to be able to talk about D3 in React Native, I need you to understand what D3.js is. So I'm going to go a little bit into this to give some background so we can all talk the same language here. D3.js is a JavaScript library for manipulating documents based on data. So you have an API that gives you data, and depending upon that data, it allows you to then bring that data to life using HTML, SVG, and CSS. When you're using D3 in the browser, that's typically you're using HTML, SVG, and CSS. Here's from their website. You've probably seen this before. This is all the things you can make with D3. Now, last year, D3 released version 4.0. And this is very important when trying to use D3 with React Native. Before D3 version 4, D3 was kind of a kitchen sink library where it gave you everything included in one library. There was no way that you could pick and choose what you wanted. It was like jQuery was just like the entire thing. Well, actually, jQuery you could be modular now too, so that's not true. But with D3 version 4, it was broken up into smaller libraries, so you can pick and choose which components you'd want to use in your application. And this is important because one of the libraries in D3 version 3 actually touches the DOM. And if you're making a React Native application, you can't. There is no DOM in a React Native application, so if you have any code that tries to do window.whatever, location.whatever, document.whatever, it will throw a runtime error because it does not exist in a React Native environment. So that's what actually opened the gates to allow you to use D3 in React Native. So for our purposes, I'm going to focus on 2 of these libraries. I'm going to focus on the scales library and the shapes library. The D3 scale library is a library that provides continuous scales, where you can map a continuous quantitative input domain to an output range. If you remember from like, high school, like math, domains and ranges, yeah, that'd be very advanced. I mean, if you did it, great. We have domains and ranges, and that's what D3 lives in. And this is what the D3 scales helps you, facilitates that. So this is a use case of it, where you're instantiating an instance of a linear scale and setting the domain, like your input data, to the range, the output data. So in this example, you're making your Y scale. Let's say you're plotting test scores from 0 to 100. That's your domain, 0 to 100. And you want to show that on your website. And you have 640 pixels of height that you want to show it with. So let's say someone gets a 50 on the score. They have other issues there, but you want to actually show that accurately on the scale, so that would show 320 pixels. Likewise, if they get an 80, it would then be 512 pixels. And as these domains and ranges get more complicated, this utility functions become even more important when you're actually using and manipulating data. Within the D3 scale library, there's also timescales. And the big difference here is that your domain is now temporal. So rather than being linear from just integers or numbers, the domain is now dates. And that's usually helpful when you're graphing over time, because you want to have a domain in time. And again, here you have a domain of year, month, day to another year, month, day, and you're plotting the x value along the graph there. Cool, so that's D3 scales, how you get from your domain data to your range data. So let's talk about D3 shape. This module provides shape generators. And this is where a lot of the power of D3 comes into play. One of the shape generators provided is a line generator, if you want to actually plot a line. And this line generator can be used to compute the D attribute of the SVG path element. So what is an SVG path element? I'm not going to get too in-depth into this, but in an SVG document, fragment, or document, you have a path element. And that is the most versatile element that you have available to you. If you ever used Photoshop or Illustrator and used the pen tool, and you have those points where you're actually plotting things, that's kind of similar to the path element, where you discretely say where the points on the path should lie. And the way that you configure that is via the path elements D attribute. Okay. So this is an array of data. You have dates and values, and you have an instantiation of a line generator function. And then you're creating X accessors and Y accessors. This is sort of pseudocode. And these X and Y accessors are required because when you feed in that array of data to this shape generator, it goes through every object in that array and says, hey, where should the X and Y point be for that line in my graph? And these X accessor says, hey, here it is, off that object. It doesn't want you to, it doesn't make any assumptions of the shape of your data. You just configure it and tell it how it is. So it's highly configuration-based over convention-based, so it's very flexible. And that long string that starts with M is a fun D attribute value. So if you actually want to hand create that, have a fun weekend. I'll use D3 shape to do that instead. And that's where you take that path data and inject it into the path element. Cool, so now you kind of know what you need to know about D3 to actually use it in React Native. So you all are now D3 engineers, put it on your resume on LinkedIn, and you're welcome. So how does D3.js work with React Native? How do you bridge that gap? So let me take you back a few libraries to this library called Art. This is off of their repo. Art is a retained mode vector drawing API. That is a fancy way of saying that you can create an SVG element using kind of an OO syntax, where you can instantiate art.surface as the created point of the art element, make an art.group, then art.rectangle, 100 by 100, move it to x by y, 1010, fill blue, and what comes out is this SVG element. So rather than having to make a string, concatenate it, and all those things, you can use this OO way of programming to make an SVG element. So that's cool. OO's nice. We know it. But React's functional. We want that. So what should we do? React Art. This is another library. It's under the React.js organization. It is a library that provides React bindings to the Art library. So instead of that OO syntax, you can instead write a React component using these components: surface, group, rectangle. So one step further, we have React Native Art. And one thing to know about React Native Art is that it actually has some native components to it. So you can't just start using React Native Art in your React Native application, because when you use those JavaScript APIs, as was discussed before, it has to talk to that corresponding native library. And by default, those native libraries are not included. That was a decision made by the React Native team because they're not small. So their thinking was, have it be an opt-in for that functionality rather than by default bloat every application. So before you use React Native Art, you actually have to include it in your native library. For iOS, you have to explicitly link it. If you use Android, actually, in this case, Android's better, where it can actually dynamically include the libraries for you. Or actually, I think it's included by default, and then ProGuard just strips it. So it's nice, and you don't have to worry about it there. But this is maintained by the React Native team. It's in the actual repo. You can see the path there. And this is what a React Native Art component looks like, just like the React Art component. And there's that fun little D attribute. So that's kind of the bridge. So I'm going to walk you through making an example application with React Native Art to give you some like hands-on experience of using this. Now that you have this background in React Native Art, and D3, and React. This is an example application where you can put in an address. Central Park. This was last summer, so that's why the weather's a little bit hotter. And then here you can actually animate between two graph points. This repo, this actually application is on my repo. I called it Better Weather because it's not worse. But free to fork it. I made the first couple commits instructional as possible, where you can see the gradual progression of functionality being added to the application. So if you look at the first 4 commits, I believe, you can see the commits composed in a way that should be illustrative. The later commits are mostly me just like maintaining compatibility with the new versions because React Native moves way too fast. They're slowing down, thank goodness. So let's get our hands dirty and build. I don't do live coding because I like to hit spacebar instead. So the first thing you have to do is actually link the native code. If you're using this for Android, you don't have to worry about it. It just works. But there is a guide on the React Native website that shows you how to link the native code to your native application. So this is the application. This whole page is the weather page. This is the React components with a view, header, weather graph. This is the weather graph here, so let's drill into that weather graph component. This is the render function of that weather graph component. Forgive me if I go too fast, for I have done this before. You can ask questions afterwards as well. Here is what we're talking about. So in React Native, let me actually back up. There is the shape element in the React Native Art library, and that is a direct parallel to a path element in SVG. It's just called shape in React Native, but it has the same D attributes as you would using an SVG path element. So you have here the D attribute with this line graph variable, which comes from the state. So let's figure out how it gets on the state. I have here this function called compute next state, so that this is ran both when the component is first created and once when it's updated as well, because when you change from max to min, the properties change, you want to recompute things. So this is just nice little like clean, dry code. Wear a poncho, very dry. So this is the actual function, compute next state, bless you. Welcome. So the first thing here is this graphutils.create line graph, which is a utility function, which we're going to get back to in a second. But after that, we actually set the return value on the state, which is where that line graph.path value comes from. So, bless you again. So where is this data coming from? So when I was trying to figure out an example application, I looked far and wide to find some good free APIs that we could use. Eventually, I used forecast.io, which is now Dark Sky, which is my go-to weather forecasting application. It's wonderful. Heavily recommend that you give it a try in your morning routine before you figure out should you bring an umbrella or just go with a t-shirt because this winter is so warm. This website provides a very nice API, which is free to use up to a very high amount of usages. Sign up, and you get back this very nice JSON response for the forecast for the next couple of days. So this is the actual data that we're plotting over in our D3 graph. So we're using the daily property, which is an array of dates. I can't read anymore. One of the properties being temperature max and temperature min. It's kind of in the middle there. That's what we're actually using to plot over as our y values. Y. And then time is the date values. So let's delve into this graphutils.create line graph. The way that this code is structured is to try to be as, respect the boundaries of everything. And what's nice is that this graphutils module is where all D3 functionality takes place. So you could actually take this same file, run it in the browser or in Node, and it would still run because there's no dependency. It's just JavaScript in D3, and it's just functions making functions. So it's very agnostic to environment, which is nice and healthy. So at the top of this file, you have some imports from the D3 scale, D3 shape, D3 array. I'm making my pseudo D3 object that I can use later. This is the function, create line graph. The first thing that we're doing here, as we saw earlier in this talk, is we're making our X scale, which is over time. So we have scale time. Our domain is date 0 time to last datum, my favorite word, datum. And the range is the width of our iOS device. And it's here as a variable because if you have an iPhone 7 Plus or an iPhone 7, you have to be flexible. So you can just have it as a width that you can easily change the output range that the graph is being rendered into. After that, we're doing our Y scale to see the actual temperatures. Here you can see we're using this D3 array.extent. And what that does is over an array, it gives you back the minimum and maximum value of that array. And that's good because if you were to plot between 0 and the max value, the fidelity in that graph would be crap. Because if you have like 0 to 99, 98, 97, you can't really see that nicely. So it's better to have that range that you can then zoom into and just see that when you're actually checking the weather for the next couple of days. So that's extent, making a linear scale. The domain's there. We call .nice, which is a D3 helper function to just round things off and make it literally nicer. So if you have like 72 to like 78, nice will make it 70 to 80. So it's a little bit nice and rounded. And the range you might see here is inverted. The height is first, and that's because the coordinate system in an SVG element starts from the top left. And you have to account for that when computing the actual D3 graph. And this is a common D3 trope, really, to just invert the height to actually have the graph rendered as you want on the page. From there, we're making our line generator. Here we have the X and Y accessors where we're passing D as the object in each of those arrays, like that temperature max, temperature min, time. We're passing that through an X accessor and Y accessor, which says, hey, where is this value coming from? So like X accessor will be .date. Y accessor would be like temperature.max or temperature max. But then we still have to convert that to our range because that's in our domain. Like the temperature max is in our domain, and we have to get that into the range. So we have to then pass that value into our scale function to actually have that correct value when rendered on the page. From there, you actually use the line shape generator, give it the data, and out pops out the path, and you get your graph in D3. Oh, man, yes. Oh, man. No, applause to you. Oh, my God. If your head doesn't hurt, then I'm jealous. How am I doing on time? Good. Next thing, I'm going to go over this a little bit quickly because I think I'm doing a little bit slow in time, but you want to use labels and axes to your graph. The easiest way that I found to do this actually was to actually just use plain old React Native components. In D3, you actually have, and in SVG, there is a text element. I could never figure out how to make that work with React Native, so I just went straight to using plain old React Native view and text components. And then to do that, you just need to return more data from the line graph generator. So before it was just returning the path property with the actual like D value in the SVG shape path. So now we have to extend that to actually include the scale functions. And then we're actually mapping over our array of dates, our array of data, and returning back the actual X and Y positions in our iOS view. And then by taking that data here, we can then simply use React Native to just absolutely position where those things should be in our actual view. So with left, we have some like offsets to make sure that they're like centered on things, like that. With the Y's, same thing as well, just using straight up views and text. Here, there, style. So what's cooler than graphing in React Native? Animating graphs in graph. So when you actually want to change from max to min, you have to make buttons where you have these control buttons. So when you press them, you have the on press to set max, which is this, which you're doing partial application with bind to set the new value here, which then updates the state. I know this is fast, and I apologize, but you can delve into this more in depth later, which then, in calling set state, causes it to re-render. And then when you're changing from show max to show min, you're changing the y-accessor function. Because rather than returning temperature min, you're now turning temperature max. And that is what's changing when you're going from min to max, which then causes weather graph to re-render, which causes component will receive props to be called, which causes this function to be called. Again, this is in my project, so you can read it without me yelling at you, which is always calmer. So here, there's some code to like grab the previous graph object that we can then have the next graph object available. We're saying if the props didn't change, if the props did change, go into this function. We're taking the path from and the path to. And this path from value is actually that D value given to the shape component, that long M100 gobbledygook string. So that's path from and path to. We're using a request animation frame, which you'll see in a second, but here we're canceling it early. We're actually cheating with animating the labels, where we're using layout animation to use to allow React Native's framework itself to animate it for us for cheating. And then here we're actually using the art library directly. The art library actually exposes a tweening function where you can actually tween between SVG path D attribute values. So if you've ever done tweening before, you know that it's a process of calculating the intermediate values of 0 to 1 over a set amount of time. So if you want to have from 0 to 1 over 10 seconds, at 5 seconds, your tween function will give you 0.5. Just standard like animation principles there. This morph.tween function allows you to do that over a path D attribute string value. So here we're making this here, and we're calling animate, which goes into our animation loop. We're using request animation frame because that's what you should do. And then this is a lot of boilerplate code, which I'm not going to go into right now, but it's documented here, where you have the delta, how far along in the animation are you. If you are above 1, that means that your animation should be complete, so let's stop. Otherwise, let's compute that tween, the value in that tween during that duration, update the state, and kick off the animation again. And that's what actually gives you this animation here. Again? Well, I'm done though. But yeah, that is the talk. React Native and D3. These slides are online on Speaker Deck. And yeah, thank you. Yeah, questions? Yes. So the question is, what framework do you get with request animation frame? Request animation frame is actually implemented with the React Native framework actually does take into concern the ramifications of what request animation frame mean in the browser as well. So you do get a little bit more proper scheduling of events. It's been mostly fine. I mean, you saw the animations at the beginning. That was both animating tweens of paths as well as opacity as well. I haven't really pushed the boundaries, so I can't fully say, unfortunately, but definitely do that and let me know. But this is like a very brute force way of doing this, and like for my purposes, it has been fine for the most part. One thing to mention is that when you are messing around with React Native art, if you put in an invalid value in the D attribute, you get a hard red box when you run the application. Like, it does not play well at all. And a lot of my time was spent just making sure that never happened. Because if that happens, like, bye-bye birdie. Like, the cat got the bird. Yeah. Does that answer the question? All right, cool. Any other questions, concerns, debatable topics? Well, thank you. Hopefully you learned something.
All right, thank you, Harry. So, just a couple of closing notes. If you are a company, a startup, an employer that is looking to hire engineers, whether it be React Native, I hope so because you're here at the React Native NYC Meetup, or any other type of engineer, we won't have the time for you to come up and make an announcement, but if you want to stand up so that people can see who you are, and then anyone interested in speaking with them, you could walk up to them once we're mingling. So, okay. And obviously, the team at Oscar Health as well, they had mentioned that they're hiring across the board. So, thank you, Stan and Harry. Awesome talks. I do want to mention we do have a Slack channel. If you're not on it, the link, I'll post the link in the Meetup page, but the link is reactnativenyc.signup.team. I also want to thank all of you for coming here tonight. Again, I said it before, without you, we don't have this Meetup, so thank you. And thank you, Oscar Health, once again for having us here. And that is it. Good night. We're going to mingle for a little while, so if anyone wants to hang out,